I say go to cluster, this will actually take me to a Hadoop cluster running on Windows Azure. So what would I be doing with this cluster? I would be taking a look at the data, the behavioral data, and I would be asking questions of the behavioral data. Let's see if this is going to come up. It's still thinking. So while it's thinking, I'm going to go back to my slides. So in the US, when we're thinking about big data, we're thinking about really two different pivots. We're thinking about relational, so SQL, or no SQL. We're thinking about on-premise, or we're thinking about in the cloud. Now, one of the things I've been learning in my first visit to India is that different vendors, different cloud vendors, have different levels of build-out of their infrastructure. Amazon is mature. When I was in Bangalore, Amazon is making a lot of business. They have data centers in India. They are really, very aggressively building out on the cloud. Google has not yet opened their data centers in India. They are making plans for that in the very near future. So I think it will be quite interesting for you students to be paying attention to both Amazon and Google. Because as Google opens their data centers in India, they will be quite competitive with Amazon. And students who are familiar and comfortable with both environments will be quite valuable to their employers. Even though I worked at Microsoft, I will tell you honestly, I believe Microsoft's implementation of the cloud is not yet mature. I hope that they improve their product, but for my customers, I am working with Google and I'm working with Amazon. Okay? All right, I opened my talk with big data talking about Hadoop. But I will tell you honestly, it's a very interesting world in the NoSQL, or the non-relational world. Because Hadoop is one of over 120 different NoSQL databases. It's quite overwhelming. So what do? Do you just study all day and all night and learn 120 data? No, we don't do that. You have to select a subset of the NoSQL databases. You have to understand which types of databases solve which types of business problems. So to do that, I've created this subset, which I hope will be helpful to you when you're studying. You see on my slide, I have 5 different categories. So 5 types of business problems. What I would recommend is that you understand each of these 5 types, and I will be going through and talking to you about it, and you select one NoSQL database from each of the 5 to have expertise in. I have found that to be a successful strategy that meets my customers' expectations. So, should be good news. You don't have to learn 120 databases, only learn 5 database systems. So to that end, in the NoSQL world, there are graph databases, which are best at capturing the connections between points of data. Think of social networks, Facebook. Okay? There are wide column databases, as shown in the center, where you have a key value and then you have a column of varying lengths. These are also called schema-less, because there is no formal schema. There are document databases, shown in the center, and the text that is shown is JSON. I think of it as a type of XML database. Before I joined Microsoft 5 years ago, that was a popular thing. It doesn't seem to be as much now. Replaced more by JSON. And then there are simple key value stores. And there's 2 different varieties of key value stores. One is persistent, save it on disk. And the other one to me, which is more interesting, which is volatile. Volatile key value store. So key and value. You can think of them as cache. But it's a type of a database. It's a different way to think about it. So when you're thinking about solutions that go beyond relational, because you have large volumes of data, that's the general reason to do it, then you have 5 different categories to select from. So in the category of graph, my recommendation for you is to look at either Neo4j, which is an open source database, or if you wish to look at an online database, look at Freebase from Google. This type of database structure is best, as it says here, for data situations where you have many-to-many relationships, self-joins that are recursive, and when your business objective is to find connections between the data. Social media is a very common example. Column database is where I was going and showing you Hadoop and HBase. Wide, sparse column sets, schema-lite. Another popular one in the US is Cassandra. Google's cloud runs on an implementation of this. This is on the very last line. The GAE, the Google App Engine, High Replication Data Store. To get more detail about column databases, there are actually two types. Type A is a column family, as shown in the picture there. They are not relational, and they are what are called sparse. They have empty space. So again, to have a deeper understanding, HBase or Hadoop, Cassandra, and the thing I mentioned in the very beginning, SQL Server 2012, the semantic model, are column families. Type B are column stores. They're actually a type of relational. They are dense rather than sparse. And an example in the SQL Server world is something called a column store index. When you put a column store index on a table in SQL Server 2012, it's stored in columns rather than rows. And the query optimization is 10 to 15x with no indexing. So the next type is a document database. And the one that I've been doing the most work with is MongoDB. These are very lightweight databases. I'm going to actually do a demo in just a second. Very common in startups where you don't want to pay licensing, you don't have a DBA, you aren't really sure of the formal structure of your data, and you want to just get up and going really quickly. Now, one of the things that I found interesting about this is that I've been able to leverage skills that I had in the relational world. So it's quite interesting that MongoDB itself is, you can see here, 531 megabytes. The entire product is 531 megabytes. It's an open source database, very lightweight. It's free. The way that you install it is you copy it. So you just copy it, and then the way that you run it is literally, let me move it over so you can see. You literally just change your path and you run MongoD, the Mongo daemon. And then you set the path of the database. So quick, simple, but yet it still has some of the capabilities that you're going to want for optimizing your queries. Now you can work with MongoDB from the command line, and many people prefer to. But for the purposes of introduction and demonstration, what I've done is I've got a tool that I commonly share with people. And this is called MongoView. This costs $50 US. So $50 for the tool. So what MongoView allows you to do is to work with your MongoDB set of databases as if it were sort of, you have the Oracle Manager or SQL Server Manager, so very, very easy. And it allows you to get started in a very simple and fast way. So you can see inside of here, I have my databases, but as you drill into them, you're going to see that we have some differences. You're going to see that unlike in a relational database, we do not have tables. We do have databases, but we don't have tables. We have collections. So collections are simply groupings of objects. They're similar to tables, but not the same because they don't have the structure around schema. So if we wanted to take a look at one of these, we would just double click. And you can see that we have a key, and then we have some data associated with it. And the data does have types, so we do have light data typing here, unlike an HBase. Now if we want to, this tool allows us to look in a very familiar way. We can look at it as if it were a table. If it were nested, which you can nest, you'd have a little plus. But the actual way that this is stored, as I was saying, is it's actually BSON, binary serialized object notation. It's JSON. And when you make changes to this data, it's stored that way. Now why this is interesting is because you get some of the features that we're used to with Oracle or SQL Server, but you don't have the overhead. So again, for startups is a use case for this. So what are some of these features? You can have indexes. By default, you get a primary key, and you get an index on the primary key. And I'm assuming here that you've done some study with Oracle, and you've understood that you can add indexes to Oracle tables to optimize queries. It's the same principle here. The same principle here. Now, what's different, going way back to the beginning of my CA, AP, CP, my consistency, availability, and partitioning discussion, MongoDB is having high availability and infinite partitioning, but it does not have transactional consistency. If your business need is to be transactionally consistent, you must write that in the business logic layer. It's a very important difference. So you must use the right database system for the right business situation. All right, let me go back. Another example of a document database that's quite popular in the United States is CouchDB. So my recommendation would be that you study Mongo or CouchDB. Also, I'll give you a tip. There is a company that supports MongoDB. They make their profit by going out and helping implement it. They're called 10Gen, and they have free online training that's quite excellent on MongoDB. So if you want to study, in addition to what you learned in school, I would recommend you take a look at it. Okay, the next category of databases is key value. And I said that they were schemaless, and they were persistent or volatile. So there are two examples that I work with. One is on AWS, and the other one is something called Project Voldemort. So I'm going to go ahead and show you on AWS what DynamoDB looks like. So this is Amazon Web Services. This is Amazon's cloud for developers. Amazon, of course, has a set of services for consumers, but this is for developers. Now, if you try out Amazon, they have a good free first year offering as a new customer. But I would caution you that you need to pay very careful attention to what they are charging you, because it's a very common situation that people will start studying Amazon and they will incur fees because they really don't have a student offering as far as I know. So these are their various services. So they have compute services, they have storage services. If I scroll down here, they have database services, and they have other services. And again, just as an aside, I'm here to talk about big data, but big data and cloud are kind of intertwined. Amazon is the market leader. If you want to be employable, if you want to have expertise in cloud, the number one thing to have expertise in is Amazon. It's quite interesting. I just spoke at the US 3 weeks ago at the largest SQL Server, Microsoft SQL Server convention in the world. And the topic I spoke on was Amazon. Now what I spoke on was something slightly different. I spoke on SQL Server on Amazon's cloud. It's actually quite embarrassing for Microsoft. Amazon has done a better job